Just a short impromptu video. I've been spending a lot of time in the garage, probably like a lot of people, just waiting for the economy to turn back around. I got this nice little block here from PH Tool. It's got a side drill hole in it, and then this straight slot to simulate a side drilled hole, and then a curved slot to simulate a curved hole. And it's been living underwater for most of the last week or so. And I'm going to show you some interesting things about beam divergence off the ID. I'm going to put the probe here and I'm going to rotate it circumferentially, and we'll watch the hole signal come in and out. What we're looking at here, this is any indications you see in here are going to be after reflection off of the ID, and any indications down here will be after reflections from the OD. So this little indication you see here, which is where the cursor is lined up now, that's actually the corner trap signal from where the hole breaks the OD. So we can say that's the ID, that's the OD, and that's the ID again. So as I move the cursor throughout the scan, you'll start to see the actual signal from the hole itself start to appear. And the first thing you notice is, wow, it's really long. Mind you, it's a time scan, so don't bother looking at the millimeter markings on the axis. But you'll notice it's really long. And that's, of course, because when the probe is sit here and the sound beam goes down to the ID and it bounces and spreads out, it diverges, right? So the beam becomes very wide. So the length of the whole peak is exaggerated on the after the first bounce off the ID. Now, oppositely, you'll see this signal right here. This is actually the signal from the OD, and after the sound bounces off the ID, it comes back up and hits the OD, and the OD tries to undo what the ID did. The ID made the beam diverge, so the OD is going to try to make the beam converge, and boy, does it ever. The signal from the hole becomes just a tiny little peak. You can see there it goes and it's gone, and we'll watch the S scan. You can see it go and fall away quite quickly. And then as we get towards the end of the scan, you will see the corner trap signal pop up again. Beam divergence off the ID of the pipe is something that we knew was already there anyways. It's just kind of a neat way to look at it using the extraction cursor and the end view. And beam divergence is also the reason why you see this little bump here on the TCG curve when it goes from the first direct shot to that one that after it bounces off the ID, the machine needs a lot of gain to compensate for the increased divergence. And then when it goes back down to the reflection off the OD, it needs less. That's why when you do a TCG on a pipe, it may give you this little funny bump. Don't worry about it. That's normal.